We're now on question 2C. C1, if alpha, beta are roots of 2x squared minus x plus 3 is equal to 0, form the equation whose roots are, find the equation whose roots are alpha squared plus 1 and beta squared plus 1. Solution. We know the general equation is written as x minus alpha plus beta x plus alpha beta is equal to 0. That's how we write the general equation. Then we are saying we need to form an equation whose roots are these. So you can write this as x squared minus, we call this the sum of the roots, and this the product is equal to 0. Now let's find the sum of our new roots. Our new roots are alpha squared plus 1 plus beta squared plus 1. This gives us alpha squared plus beta squared plus 2. But we know that alpha squared plus beta squared is the same as alpha plus beta squared minus 2 alpha beta, and then plus 2. Then from that, the product of our roots is alpha squared plus 1 multiplied by beta squared plus 1. That is alpha squared beta squared plus alpha squared plus beta squared plus 1. When you expand, and so we have done so many things. So it's becoming very, very easy to solve. So we know that if we have this separation of powers here, we can just put the alpha beta in brackets and the power goes out. And then alpha squared plus beta squared from binomial, we see that this is just alpha plus beta squared minus alpha beta plus 1. Then now we go back to our question. From this equation here, we know that alpha plus beta is given as negative b over a, which is equal to negative 1 over 2, which is half. We also know that alpha beta is given as c over a, which is 3 over 2. So we bring now alpha plus beta. We have found it's half. So we have it here, half squared minus 2. Alpha beta is 3 over 2 plus 2. So we simplify this, we have 1 over 4 minus 3 plus 2, which is 1 over 4 minus 1 over 1. And this is negative 3 over 4. We got alpha beta. Alpha beta is 3 over 2 squared plus alpha plus beta is half. Hello?
There where you had to change alpha squared plus beta squared. Was it not supposed to be minus 2 alpha beta?
Was not supposed to be minus
2 alpha beta.
Yeah, it's here.
And not there, and the other one.
It's here.
Yes.
Oh, it's supposed to be 2 here. You're
Yes.
right. So put the 2 here. So that we get 9 over 4 plus 1 over 4 minus 3 plus 1. So we have 10 over 4 minus 2 over 1. 4 down, 10 minus 8, which is 2 over 5, which is 1 over 2. So we have found the product, we found the sum. So our equation then becomes the x squared minus the sum is negative 3 over 4 x plus the product is 1 over 2 is equal to 0. If we multiply throughout by 4, we have 4x squared plus 3x plus 2 is equal to 0. So this becomes our new equation that we have formed out of the information given in the question. Five marks. Five marks. So nice. Next, part 2, given that 3x plus 2 is a factor of f of x is equal to 3x squared plus.
I'm just asking for the previous page.
So 3x power 3 plus ax squared minus 4x plus 1 minus 4x minus 4x minus 4. Okay, so the question says, given that 3x plus 2 is a factor of f of x is equal to this, find the value of a. Find a. We wanted the previous logic here. So find the value of a. So how do we find a? We have the information that 3x plus 2 is a factor. So we know that if we get 3x plus 2 and equate it to 0, it will give us x is equal to negative 2 over 3. If we take this x in this function here, we should get 0 since it's a factor, implying that we have 3 negative 2 over 3 to the power 3 plus a negative 2 over 3 squared minus 4 negative 2 over 3 minus 4 is equal to 0. So we can find A. Everything else is constant. That is negative 8 over 9 plus 4 over 9A plus 8 over 3 minus 4 is equal to 0. Then we take these other numbers the other side and only leave 4 over 9A on the left. So we'll have 4 minus 8 over 3 plus 8 over 9 with common denominator 9, or we can just multiply throughout by 9 so that we get 4A is equal to 4 by 9 is 36 minus 8 by 3 is 24 and then plus 8. So we're getting 4A is equal to 36 minus 24, that is 12. 12 plus 8, that is 20. And then divide by 4, divide by 4. So we obtain that A is equal to 5. And then we are told next that use the value of A found in 2 above to factorize the equation completely. So 3, use the value of A in part 2 to factorize f of x. So we have f of x is equal to 3x3 plus 5x squared minus 4x minus 4. The good news is that the factor is already there. We have negative 2 over 3 as a factor. So if we correct the coefficients, we can then use synthetic. If we multiply here, we get negative 2. Do the addition, we get 3. We get negative 2. Do the addition, we get negative 6. We get positive 4. Sorry. Okay, so when you do the addition here, we get 0. So we have that f of x is equal to 2x, 3x plus 2 multiplied by 3x squared plus 3x minus 6. The question says factorize completely. So let's see if we can get factors here for 3x squared plus 3x minus 6. The product is negative 18 and the sum is 3. So you can do 6 and 3. So that you have 3x squared minus 3x plus 6x minus 6. So you get 3x, x minus 1 plus 6x minus 1. So that when you come here, we have 3x plus 2, and then we have x minus 1, then we have 3x plus 6. So this becomes a completely factorized function. And you leave it there. Or if you want, you can still factor out the 3 and write it as 3 2x plus, x plus 2, x minus 1, 3x plus 2. So I factored out the 3 from here and then wrote it as the first thing. And then wrote the other one because I'm multiplying, so I can arrange them in any order. So that's the factorization needed there. And that's why question 3 ends. Why don't you come there? Okay, so next we go to question 3. Okay. Question 3a, A1, if sine theta is equal to negative 7 over 25 and theta lies in the fourth quadrant. Find tan 2 theta. Solution, we are told that sine theta is equal to negative 7 over 25, but we haven't forgotten what SOHCAHTOA is and how useful it is. So having been given that it lies that theta lies in the fourth quadrant means that we are allowed to form a triangle in the fourth quadrant with the angle theta attached to the y-axis there and to the x-axis there. And we know that sine is opposite over hypotenuse. So opposite is this side here, which is the negative of y. So it's negative 7. Hypotenuse is 25. If you're avoiding confusion, you can actually write negative 7 on the actual angle and say negative 7. There's no problem. For as long as it will help you find the solution. So you need to find the adjacent side of theta So you find the adjacent side of this, and how do you find the adjacent? You say, okay, the adjacent using the Pythagoras theorem is 25 squared is equal to adjacent squared, the side we're looking for, plus opposite squared, meaning that we have 25 squared is 625. 625 is equal to a squared plus 49. And then take this the other side, you have 625 minus 49 is equal to a squared. Then square root, so that a becomes 625 minus 69, we get 556, and the square root of this guy
24.
24. When you round up
24 when you subtract the square root.
okay, right. The square root is 24, so we put 24 here, and it is positive because that's the x-axis. And so we can now find tan 2 theta. So tan 2 theta is this. Okay, it's the same as tan theta plus theta, which is equal to tan theta plus tan theta over 1 minus tan theta tan theta. From the expansion of tan A plus B, which is tan A plus tan B over 1 minus tan A tan B. So tan theta, that's the same as 2 tan theta over 1 minus tan theta squared. So 2 tan theta, we need to get tan theta from the triangle. So what is tan theta? Opposite over adjacent. So opposite is -7, adjacent is 24. So we'll have 2 by -7 over 24 over 1 minus -7 over 24 squared. So we get -7 over 12 over 24 down, and then we'll have 24 minus 49. This is giving us -7 over 12 multiplied by 24 over, what is 49 minus 24? That is 5, 2. So it's -25. So it being -25, so it being -25, we get 12 into 24. So 12 into 24, that's 2. So we get -14 over -25, which is equal to 14 over 25. So we have found, hello?
You square 24.
Yeah, I didn't square 24.
You are bronze, sir.
Yeah, it's penalty. Yeah. I was thinking it was going to square it, so can't it mean to square it? Okay. So on top, it's okay. Then down, what's 24 squared? 24 squared is 576. Come on. It's a question of this. Okay. So we get 1 minus 49 over 576. Okay. Yeah, that's okay. So 576. Then you get 576 minus 49 next 7 over 12. So get next 7 over 12 multiplied by, what is 576 minus 49? That's 527 over, that's 526 over 527. So natural derivative. So multiply 576 by 7. You get negative 4032 over 527 by 12. 6324. You can simplify if you want. Then part 2, in the next 6 minutes, we'll be able to prove part 2. Prove the identity. Cos A plus tan A over sin A cos A is equal to cosec A plus sec squared A. So here we can pick the left-hand side and show that it's actually the right-hand side. So cos A plus tan A is sin A over cos A over sin A cos A, giving us cos squared A plus sin A over cos A over sin A cos A. So you can say this is over 1 also. So that we write on top there, we have cos squared A plus sin A over cos A multiplied by 1 over sin A cos A. So get, if you multiply, we'll have cos squared A plus sin A over cos squared A sin A. So that when we split, we'll have cos squared A over cos squared A sin A plus sin A over cos squared A sin A. So this here gives us 1 over sin A plus this here 1 over cos squared A, which is equal to 1 over sin A, that is cosec A. 1 over cos squared A, that is sec squared A. This is what we have on the right hand side. Remember what we said when proving the identities, you pick one side and show that it's equal to the other side. You don't move with them. The left hand side is equal to the right hand side. You keep moving like that. Then you won't be solving anything. And again, I also mentioned that if you find that they are mixed, if they are mixed, cos, tan, change tan to cos and sine for you to get the other forms. Okay. We can log out and log back quickly so that we come back and do.
Just for a previous screenshot so that I screenshot. All right, thank you.
Okay.